Welcome to our series of short educational videos which describe important concepts of building performance. This video discusses the following topic. In hot climate, humans have to reject, or we call it lose, body heat to maintain good thermal comfort and stay healthy. We also are going to speak about main heat loss processes that keep humans cool. The human body creates metabolic heat. Metabolic heat is a process which converts chemical energy, which we take on in the form of food, to heat which can be used to perform work. And in the process, we are creating also a lot of heat energy. The level of heat energy depends on the level of activity. When we sleep, for instance, we do not create a lot of heat, but if we sit quietly and writing, we create a little bit more, same as when we're walking, a little bit more. And then in the extreme, when we are engaged in very heavy physical exercise, like going into the gym and working out, you can see all people sweating there. So we create a lot of heat, and heat loss is required in hot climates. The human uses four main mechanisms to lose heat, and we can divide this in two categories. We call this latent heat loss and sensible heat loss. Latent heat loss is associated with perspiration when we sweat. Sensible heat loss is associated with radiation or radiative heat loss, convection, and conduction. You see it on the graph here, that poor body is very hot, so he has to lose heat, right? So he can do this in terms of evaporative heat loss when he's sweating, convective when air is breathing over him, or radiative loss, heat loss, or conductive heat loss. As we said, there are two types of heat transfer for the humans which we can use. Sensible heat loss, and this heat loss is associated with a temperature differential. So heat is rejected or transferred, we can also say, from cold air or cold surfaces to cold air or to cold surfaces. And we see here the heat goes from the higher temperature to the lower temperature. The second one is latent heat loss. And this heat loss is in the presence of phase change, in our case evaporation. And the heat rejected or lost is when water evaporates or perspiration evaporates on the skin. So here the temperature is not transferred, but it is absorbed by actually evaporating water. Let's just go through these different heat loss processes. Here we have convective heat loss of moving air. You see here air is going over the body and cooling it. More air. So the amount of heat loss is larger with strong air movement and colder air flowing over the body. I think a lot of us have already experienced this. When it's getting hot, we turn on the fan. The next mode of heat loss is radiant heat loss. And here, infrared waves from warmer body go towards colder bodies. The heat is actually radiating from this poor fellow against something cold. It doesn't always have to be a block of ice. It also can be like a cold wall or a ceiling. That feels really good. So the specifics here is that no airflow is required, and also no conduction is required for radiant heat transfer. The next one is evaporative heat transfer. So the heat of evaporation is used to cool the body. And we see it in this little sketch. The poor fellow has a lot of sweat on his skin, and while the sweat is evaporating, heat is absorbed. So the poor fellow can actually reject heat in terms of evaporative heat loss. No sweat. And evaporative heat loss can be increased with convection. The next heat transfer mode is conductive heat transfer. And this is heat transfer through contact of objects with different temperatures. Here we see a poor fellow sitting on a block of ice or a cold surface, and his body heat through contact is transferred to the colder object. Usually you don't like that. And also usually it is not designed as heat loss mode to cool occupants. So there's a preferred combination of mechanism for heat loss. We have evaporative heat loss. We see perspiration. We have convective heat loss through cooling air or some kind of forced air going over the body. And we have infrared heat loss, radiant heat loss by means of infrared waves going from the hotter to the colder object. And again, like, it doesn't have to be a block of ice. It could also be a cool wall or ceiling. And there's some combinations, we said, which humans prefer, to have established for a good heat loss, which we also confer as like a gentle heat loss, or we do not feel uncomfortable. For instance, if the convective heat loss is too strong, we feel a sensation of draft. Or if the evaporative heat loss is too large, we actually perspire a lot. So we are getting our clothing wet. Radiant heat loss, sometimes we feel very cold if the walls or ceiling, or again, like if we're standing close to a very cold object. So there is a certain combination which is preferred by humans. And this is the following. Perspiration should be between 18 and 20% of the heat loss. The convective heat loss should be between 30 and 35, and the radiant heat loss should be about 45 to 50. So this is maybe surprising to some people, because radiant heat loss is the most effective also, and the most desired. So we have actually covered all what we wanted to cover in our short video. And now we make a self-learning assessment, and let's see how much you remember. And we would like to invite you to test yourself. So the first question is, why do humans have to reject body heat to stay healthy? The second one, what are the main 4 processes of heat loss from the human body? Third, how does the level of physical exercise correlate with heat generated in the human body? And fourth, what is the difference between latent and sensible heat? Give it a try, take time, and it really will help you to enforce your learning experience. So we are at the end. We thank you very much for your interest, and we would like to invite you to join us again in the future.